Okay, everybody, today we're doing 10.1, and this one's kind of a fun lesson because I say it that we do magic. Really what it is the rules for it. You just kind of accept it. It's one of those things that if you just accept it, it becomes pretty easy. You may wonder why it is what it is, and I may walk through a little bit of why. We'll kind of see how it goes, but I think I might just leave it as is, just because I think it's easier just to do the step and just call it good. So what we're doing is we're dealing with exponents. So far we've had exponents. Remember, the exponents are the little powers, so something like 7 to the third power, something like that. And this number has always been positive. Sometimes we've had negative numbers here, but we've never had negative exponents. So we're going to show you what to do if you have a negative exponent. And before you get scared, it's actually the easiest thing ever. So, for example, let's pretend this is a negative 3. So I have 7 to the negative 3 power. Okay? So what we say in math is that we don't want to work with a negative exponent. So you want to write the expression with positive exponents. And to do that, it's super easy. All you do is you switch placement. We're talking, by placement, I'm talking about numerators and denominators. Remember, every number is over 1 if it's not already written as a fraction. So everything is over 1. So all you do, remember, this negative 3 is tied to this 7 because it's right next to the 7, so it only belongs to the 7. Not this one, it only belongs to the 7. In other problems we've had where it's outside the parentheses, the exponent's outside the parentheses, then it does apply to the numerator and the denominator. But in this problem, it's right next to the 7, so it only applies to the 7. So this 7 is to the negative third power. Well, we want to get rid of that negative 3. And to do that, like I said, we change the position. So instead of having it in the numerator, we move it down to the denominator, and it magically becomes positive. So I would take this whole thing and move it down. And so now I've got 1. And when you move it down, whatever's down there, it becomes timesing by whatever you've got down there. You could have an X down there. We can have a number. So we move it down there, and now it becomes 7 to the third power. And you don't keep this up here. You moved it. So it jumped from the upstairs, or the numerator, to the downstairs to become positive. And when it did that, remember, we can't leave our numerator empty. We've got to have something to hold it, so we're going to leave the 1. I'm going to get rid of this 1 because if we times anything by 1, it just stays itself, and there's no real need to have it down there. So 7, this is what we had in the beginning, 7 to the negative third power is the same thing as 1 over 7 to the third. So all you do is move it upstairs or downstairs. So the way I say it is you pick it up and you chuck it downstairs, or sometimes we'll have negative exponents in the denominator, and so we'll pick it up and chuck it upstairs, and then its exponent magic, changes to the positive. And you can switch. Rarely, if ever, do you want a negative exponent. But if you, for whatever reason, need a negative exponent, I could pick this 7 to the positive third power. I could pick it up and chuck it upstairs and make the 3 negative. So notice this doesn't change. My number doesn't become positive or negative. We're just dealing with the exponent when we do this. Okay, so if I have, say, 5 to the negative 2 power, that's the same as, remember, I'm going to pick it up and chuck it down, so it's just 1 over 5 squared. Okay, and the more we do, I think the more you'll be like, okay, that seems so weird and silly and pointless, but that's just what it is. And when we get some more, I think the more complicated, I guess, or more involved that the problems are, it becomes kind of like a puzzle, and so it's kind of fun. Let's do one, and then probably, let me look really quick. Yeah, it says to simplify if possible. So they want you to, so for example, the one that we just had was 5 to the negative 2. They want you to simplify it. So let me show you. 5 to the negative 2. So I'm going to take that and just rewrite it. I'm going to write it a little further away so you don't get confused. So 5 to the negative 2. I'm going to take it and chuck it in the bottom. So I'll have 1 over 5 squared. So these two things are the exact same thing. It's just different ways of writing it. And so they want you to simplify it, meaning rewrite this as a number, because we can do 5 squared, right? We know what 5 times 5 is. It's 25. So there is our simplified version is what they're, oh, sorry, you couldn't see that. That's what they're asking for when they want you to simplify if possible. So what they mean by if possible, so if we had a problem like, I'll come down here, if we had, let's do x to the 7th, or let's do negative 7, sorry, x to the negative 7th power. So I don't want a negative exponent, so I chuck it in the bottom. I'll have 1 over x to the 7th. And there we're done, because I can't do x times x times x times x times x. I can't get an actual number for that. So up here I could get an actual number for 5 squared, but x to the 7th I can't. So you're done right here. That one, we needed to go one more step. Okay? Let's show you what we do when we have negatives. So if I were to have negative 2 to the negative 3rd power, again, notice I've got my negative 3, negative 3rd power is right next to the parentheses. So that means everything inside is getting that negative 3 power. So that means I've got to include that negative when I chuck it downstairs. So it becomes negative 2 to the positive 3rd power with 1 up top. And it's wise when we have positives and negatives to keep our parentheses. So the reason why is because, remember, it's different if we're including the negative or if it's just hanging out and getting attached later. In this one, we would get a negative regardless, but not always would that work out. Okay, so when we have evens. Okay, so 1 is still 1, but negative 2 cubed is negative 2 times itself 3 times. So I times itself 3 times. Negative 2 times 2 is 4, times 2 is 8, and it was a negative times a negative is a positive times a negative. Or you could say I have a 2 that will make a positive, and this guy doesn't have a buddy to keep him positive, so he stays negative. So it ends up being 1 over negative 8. So negative 2 to the negative 3rd power is the equivalent of 1 over negative 8. Okay? And let's do another one. Let's see, we'll do how about a fraction this time? So if I have 5, oh, there you go. If I have 5 thirds and I want to raise it to the negative 2 power. Okay, this is kind of like what I talked about before. When we have the exponent next to the parenthesis, then it does apply to the upstairs and the downstairs, our numerator and our denominator. So essentially that's 5 to the negative 2 power and 3 to the negative 2 power. Well, remember I said we don't want negatives, so we're going to pick them up and chuck them into the opposite spot so they will turn positive magically. So if I take this one, I need to move it downstairs, and then it will become 5 to the positive 2 power. I want this one positive, so I need to move him upstairs, so that will become 3 to the positive 2 power. Okay, and eventually you kind of see a trick with these negative exponents, I think, with fractions. So you can see we've just flipped the fraction and then made the positive. Maybe that won't help you, maybe it will, either way. And then we need to finish simplifying this. 3 squared, I'm going to see if I can squeeze that in there. 3 squared is 9, and on bottom 5 squared is 25. Oh. Hopefully you can see that. Okay, let's try another one. This time we're going to have 2 variables multiplying each other. So we're going to have x and x times y to the negative 4th power. Okay, this negative 4 exponent only applies to this y. It's tied right to it. Remember your exponent, if there's not one written next to it, it's 1. So this guy has a 1, so he's positive. We don't need to mess with him. The only one we need to mess with is this y to the negative 4. So I want to pick it up and chuck it downstairs. I don't want to move the x. I want him to stay. I just want the y to the negative 4 to move downstairs. We can do this because we're dealing with multiplication. So we can just pick him up and move him downstairs. And then he becomes positive. Okay, let's try another one, kind of similar. Let's do m to the 3rd x over n to the negative 5. Okay, so we're going to come down and do this one. The only negative exponent I have is this one. Remember, all we're trying to do is write it in positive. I don't need to move these. I don't want them to become negative, so I want them to stay where they're at. The only one I want to move is this guy because I want to get rid of that negative exponent. So I take him and move him upstairs, and then this negative 5 becomes positive. So I leave what's upstairs upstairs, so I have m to the 3rd times x. Now I'll have times n to the 5th. And then you're done. If you can combine, like if I had more m's repeating or more x's repeating after that, then, you know, you can condense them. But as is, m's, x's, and n's, I have all different variables, so they won't change. Let me show you what I mean. Do another one. Try a different marker. That one doesn't erase very quickly. Okay, let's do, I'm going to do a to the negative 1 times b. I don't like how this marker writes. I'm just complaining. A to the negative 1 times b over b to the negative 6th. We'll see. Okay, so before you start trying to cancel things and stuff, remember you've got to get rid of those negative exponents. Don't do this. Don't say, oh, I've got to be upstairs. It will cancel with one downstairs, because it's a negative exponent, so we don't know where that's going to really end up. So let's figure that out first. So I've got a negative up here and a negative down here that need to move. So I'm going to move that a to the first down and b to the 6 up. So I'll be left with my b that's up there, and now I have another b to the 6 that moved up, and my a to the first went down. Okay? So up here, this is saying b. Remember, it becomes times. So b times, this is b times b times b times b times b times b, 6 times, right? So I've got b now timesing 7 times. And I still have my a. You can write a to the first or just leave it as a. You don't have to write the first power. It's not necessary. But that's it. So this simplifies to that. So it's, like I said, it's kind of like a fun Rubik's Cube or something that you actually can solve without pulling the stickers off. Let's see. If I can find one from your homework that might be a little more complicated. I think they're all pretty much like that. Let's do a variable one. A variable fraction. Okay, now remember that this exponent just goes into your numerator and your denominator. You multiply it in, but we're multiplying by, these guys have an exponent of 1. So -4 times 1 just becomes -4, and 1 times -4. Oh, I put 3. So sorry. Becomes 4. I don't have you guys here to catch my oopsies. Okay. So now we're here, and we want positive exponents. So we move them, chuck them upstairs, chuck them downstairs, and I end up with 3 to the 4th up top over x to the 4th down below. And I can calculate my 3 to the 4th, so you need to do that. X to the 4th we can't, so we're going to leave that in the denominator. But I need to figure out my 3 to the 4th, which is not 12. Don't say 12. It's 3 times 3 times 3 times 3 times 3. I think I said 4 of them. Okay, so let's figure that out. 3 times 3 is 9. And this is 3 times 3, which is 9. And then we're timesing. 9 times 9 is 81. So we get 81 over x to the 4th. And we could have done 3 times 3 is 9, times 3 is 27, times 3 is 81 as well, if you were wondering why we went that way. Okay, so that's really all that part of it, which is really, like I said, kind of fun. The only other thing we need to talk about is kind of review. They just want to make sure you understand or remember what anything to the 0 power is and anything to the first power is. So if I have, even if it's a decimal, so if I have, we'll say 16 to the first power, we've kind of talked about this, that's just 16. Oh, you couldn't see it, sorry. If I have negative 16 to the first power, that's negative 16. If I have negative 16 in parentheses to the first power, that's